Hello, Course 3. Welcome to Lesson 92 on the Kaloran Show today. We are talking about areas of rectangles with variable dimensions and products of binomials. So I don't know if your mothers and fathers have ever told you, but you can't always have it perfect. The best example I can give you of areas of rectangles with variable dimensions is when Mom and Dad worked in the bathroom and they had to tile the floor. And they said, okay, guess what? Our house is not perfectly square. So when we create these tiles, we're going to have to make some cuts in our tiles to make them not even. I know Mrs. Kaloran's tiles look almost perfect and they are square. That's a joke, by the way. But you can see that we're going to have to cut these tiles, and that's going to cause problems. It's going to cause problems with our dimensions. It's going to cause problems with our area. So we're going to talk about those problems we're going to have and how we can solve them. In your first problem here, suppose a rectangle rug measures 2.5 feet by 4.5 feet. We can represent its area by writing 2 plus 1.5 and 4 plus 1/4. So over here you'll see that we have a rectangle. We have talked about multiplying mixed numbers before, but we're going to expand the idea because we're going to be getting into unknown values. So here I've sketched the rectangle again, and we're going to break the product up. So right here we're going to have our 4. Okay, so you can see there is our measurement of 4. And over here we're going to add 1/4 because we have 4 and 1/4 as our area on the top. Okay, and you can see that 4 plus 1/4 is equal to 4 1/4. Okay, so I just wanted to demonstrate that. Then down here we're going to demonstrate the area or the width of our rectangle, and we start with 2, and down here you're going to see a half. Okay, so I've kind of already split this up so that you could see the breakup of our two mixed numbers. What we're going to be discussing is how this can help us find the area, okay, in a much easier way. Maybe not for this problem, but you'll see in the next steps. So what we would like to look at first is that right here, this area, we're just going to, not that one, grab the wrong shape. This rectangle that we have right here, I'm just going to fill it in as a different color so you guys can see. Let's use yellow. Okay, and that didn't work either, so let's just try that again. Here we go. Okay, here's our yellow rectangle. So we need to find the area of this yellow rectangle. So we're going to take 2 times 4 because our width of it is 2 and our length of it is 4. So we have a total of 8 for our area there. Okay, now that is not the area of our whole entire rectangle. We also need to find the area of the other parts. So we're going to go back to a shape again. I'm going to change the color of this shape, and let's do this one green. So when I create this rectangle, it's not letting me. When I create my rectangle here, and you're going to see there's my green rectangle. We need to find that area of this rectangle. Well, right here we can see that the length of that is 1/4 and the width of it is 2. So if we wanted to find the area of this rectangle right here, we're going to have to take 2 and multiply it times 1/4. And what is 2 times 1/4 or 1/4 of 2? That would be a half, right? If we did 2 over 1 times 1 over 4, 2 goes into 4 twice. 1 times 1 is 1, and 1 times 2 is 2. Okay, so the area of that rectangle is 1/2. We're going to continue to obviously make these rectangles. You may be able to see a pattern here. Hopefully my shapes are going to work. We better use this color here. Look at that. There is our third rectangle, and we're going to have to look at the dimensions of that third rectangle. We have a 1/2 by 4. So what is 1/2 times 4? These ones are obviously very basic. We don't need to do too intensive math here, but 1/2 times 4 is going to be 2, or half of 4 is 2. So right now we can say that there's an area, and there's an area. So in our last one, we're going to be finding our last little shape down here. And let's do another light color, pink maybe. Everybody loves pink. Okay, there's our last rectangle. This last rectangle is probably the trickiest of all of them. But we can see that this length is 1/4 and our width over here is 1/2. So in order to find that area, we would need to take 1/4 times 1/2, which is equal to 1 times 1 is 1, 4 times 2 is 8, 1/8. Okay, so when we find the total area, okay, I hope that we are all going to agree that the total area is going to include all of these areas. So we are going to have to add 8 plus 2 plus 1/2 plus 1/8. And when we add those, we are going to end up with 10. And then this is a little bit of the tricky part, but here we need a denominator of 8. So we're going to change that to 8. But in order to do that, we had to multiply by 4. So up here, our numerator is going to change to 4. Remember, to add fractions, we need a common denominator. Okay, so now we have a common denominator. So our denominator will remain as 8. 4 plus 1 is 5. So our area, I don't remember what our dimensions are in, if they gave us any. Feet, perfect. Okay, our area is going to be 10 5/8 feet squared. Okay, and that's how we found this area. So this is an area model is what this is called, and we're going to continue to use this in today's lesson. So let's move on to the next one. A rectangle is x plus 3 units long and x plus 2 units long. Yes, I know you're thinking who brought the x's into math, but somebody did, and we need to know how to work with them. What these are called are binomials, if you forgot. Okay, so today we're going to be talking about a binomial times a binomial. So you can see over here that there is a rectangle, x plus 2 times x plus 3. So what we're going to talk about today is breaking that up. So we are going to create our area model like we just did on the last page. So here is our box. Okay, now we need to keep in mind that our first term is x. Okay, before we had a mixed number, now we have two terms. Okay, so our first term is x, and our second term is a positive 3. Okay, down here our first term is x, and our second term is a positive 2. Okay, so we are going to create some more rectangles. Get some good colors in here. So we're going to start right here. Oh, that was the wrong one. Okay, there we go. Alright, so here's our first rectangle. So we need to find the area of this rectangle that is x by x. We have talked about multiplying variables, so you should already know that x times x is equal to x squared. Okay, just like if we had 2 times 2, it's equal to 2 squared. Okay, we don't know what it is, so we create that value. Okay, in our next box over here, we're going to have another area. Okay, this area we will do in red. Down here we have a length of a positive 3 and a width of x. So when we multiply 3 times x, we are going to get 3x. Okay? You can see we still have some rectangles we need to calculate, so we're going to get those down here. Here's our next rectangle. We will do this one in black. So you can see we have our width of 2 and our length of x. So we're going to take 2 times x, and that is equal to 2x. Okay, and our last rectangle, yes, we get to use our pretty pink again. Okay, our last rectangle down here is probably the easiest rectangle of them all. We have a length. Our length right here from here to here is 3, and our width from this point to this point is 2. So you can see we're breaking this up into many, many rectangles, but it's making our job much easier because now when we find 2 times 3 is 6, we have 4 different areas. Okay, so when we multiply two binomials, you're going to end up with four terms. Our first term was x squared, our second term was 3x, our third term was 2x, and our fourth term was 6. Okay, so multiplying two binomials gives you four terms. However, when we add all of our areas together to find the sum of all of them, we can see that these two terms right here are the same. They are alike. So when we have like terms, we have to remember we can combine them. So right here we're going to have x squared. We are going to add 3x and 2x, which makes a 5x, and our 6 at the end. So what this means is that when I take x plus 3 and multiply it times x plus 2, my solution is going to be this pretty trinomial right there. Okay? So we're getting into more of the polynomial aspect of your mathematics, and we're going to continue. Okay? Even more fun. I just wanted to show you another demonstration of this. So what we could do here is we could show okay, this is going to be an x by x. I wanted to just mention right here that we could break this up into 3, and we could break this up into 2, because this was 3 equal parts, this was 2 equal parts. Okay, each of these are denoted by each of these right here are 1s. So you can see this is broken up into 1 and 1, because 1 plus 1 is 2, 1, 1, and 1, because these make 3. So if we have a 1 by x, each of these boxes represent an x. Each of these boxes is going to represent an area of x. Okay, so just another way to look at it here. Down here, you would have a 1 by 1. So each of these boxes down here are going to be an area of 1. And then up here in the top left corner, you're still going to have your x by x, which is x squared. So you can kind of see that we can add areas here as well, and it skips the finding like terms because you can see the like terms now more visually. We have x plus x plus x plus x plus x, which is 5x. And then at the end we have 6 constants, okay? So there's just another way of looking at that expansion. So we're going to, you can choose whichever way you would like to use. Make sure you write both of them down so you remember that there are 2 options here. Okay, so now we are going to expand another problem. X minus 3 and x minus 4. So this makes it a little bit more complex. I'm going to show you both ways just so that you can see what's happening. Mrs. Florin's going to get better at squares too. So we're actually going to draw a square in here, because this one should be a square. I'll make it a little bit smaller. Okay, so there's our square right there. So we're going to have that as an x by x. Now remember over here we have a minus 4, and down here we have a minus 3. The difference here is that now we're working with a negative. Okay, so we got to be really, really careful with that negative. So right here we're going to continue to make units. So these next boxes right here are going to represent our units. But we can continue this pattern right here, and we can continue this pattern right here. Now we can find our areas. So I'm going to once again use your rectangles to complete the areas. So we'll use a yellow one over here. Okay, so you can see our rectangle right here. We need to find that area. Remember, it is a negative 4 by x. So if we take negative 4 and multiply it times x, what is our total area of this rectangle? Negative 4x. Okay. Down here, this one should have been fairly simple up in the left corner there. You're just taking x times x, so we know that's a square, that's x squared. Okay. Down here we have another rectangle, and let's get a new color. Let's do a green. And you can see there is our rectangle there. And in this rectangle we needed to take our x times our negative 3 to find that area. And x times negative 3 is a negative 3x. Okay, your last area model over here, or part of your area model, is going to be this length, which is a -4, and this width, which is a -3. Now when I multiply -4 and -3 together, remember your rules of multiplication. Okay? Same sign means positive. Okay? Different signs in multiplication means that it's a negative. So here I have the same sign, so it's going to be a positive, and 3 times 4 is 12. Okay? In order to find the total area of this rectangle, we would need to add all of your terms together. So x squared plus a -4x plus a -3x plus 12. So when we add all these like terms together, you can see there are your only like terms. So we need to group them together. So if adding a -4x and adding a -3x, okay, remember your rules of addition. Okay, same sign in addition means that you add and then take the sign of both. Okay, so that's exactly what we're going to do. X squared doesn't have any like terms. Add them. 4 and 3 make 7x, and we're going to take the sign of both of the numbers, and then we're adding 12 at the end, and you can see, voila, you have your trinomial, which resulted from multiplying your two binomials together. Okay, so I know that this is getting longer and more intense, but I would also like to show you when you can see the breaking up. Okay, so when I draw 3 lines to break these up, okay, and then down here 2 lines to break these up. Okay. What I would like to point out is that my boxes are not exactly perfect, but this would be a -1, a -1, and a -1, because that is how we are going to get to our whole -3. Okay, then up here, these are going to represent -1, -1, -1, -1. That's how we get to our -4. So you can see in these boxes here, I'm going to have a -x, a -x, a -x, a -x. Those are going to be the areas up here. Okay, over here along this side, I'm also going to have these green parts are going to be -x's. So you can see that all of these are like terms. So you can see how many -x's you have. And you should end up with 7 -x's, okay? And that's where that -7x comes from. The area of these ones right here, -1 and a -1. This is a -1 and a -1. So what do those end up being? Positive by your rules of multiplication. So these are all going to be +1 units. So you can see that this area model is going to break your units up into your 12. That's where your 12 comes from at the end. So we're going to continue on with that, and you're going to complete your own problems. Now keep in mind that there are quite a few problems here, and this was a longer video. They're going to get shorter. Remember, it's towards the end of the book, so just bear with me and learn this stuff, okay? This is a huge breakthrough in your algebra. So keep working with it. You're doing great. Give yourself a pat on the back for making it through that whole thing awake. And thank you for tuning in to the Killorn Show.